Let's see. You've learned about really a lot of stuff the last several videos. You've learned about exponent rules and you've learned about terms and you've learned about combining like terms. Basically how to add and subtract these things called polynomials, which is a joining together of several terms with addition and subtraction. Now we're going to learn about multiplication of polynomials. At the last of the videos in this kind of little subsection of polynomials, we learn about dividing. But right now is our time to focus on we've talked about exponent rules. We've done some of these things, and this is kind of a recap of that. But now let's put it together. Like, what if we have to multiply more than one term times more than one term? What that even looks like? And that's a start. This is the start of that in this video. So let's review a couple concepts about exponent rules. Number one thing we know about them is that exponent rules only apply to exponents. Also, what we do with the exponents is always one operational level below what we see on the paper. So when we look at something like that and we multiply 3y cubed, a monomial, that's one term, times negative 7y to the fourth, that's another monomial, that's one term. The numbers multiply together like numbers should. Exponent rules don't apply to those coefficients. 3 times negative 7 is negative 21, that's fine. What we do with the exponents is one level below what we see. So when we have 3y to the third times negative 7y to the fourth, sure, we're going to get negative 21. We don't do weird things like add them. We don't add the coefficients. We do that to the exponents, though. The exponents say, well, if I'm multiplying, if that's an operation that's on the paper, I'm going to be doing one level below. I'm going to be adding. So and the reason why I'm covering this is because we deal with the same exact concept for the rest of our problems. So when we see 3y to the third times negative 7y to the fourth, let the numbers multiply. Get negative 21. But what we do with the exponents is one level below the operation we see. So we see y to the third times y to the fourth. 3y to the third times negative 7y to the fourth, negative 21. Y to the, let's see, I'm seeing multiplication. I should be adding the exponents, y to the seventh. That's something we covered in exponent rules, and we should be feeling really comfortable about that. And that's great if you are. I'm really happy with that. The next one's very, very similar. It doesn't matter how many factors are within each term, we can still multiply two terms together fairly easily. Let our numbers multiply. So when we're talking about exponent rules, it's not affecting coefficients. 4 times 3, man, it's 12. It's always 12. Put 12. And because our terms are factors multiplied together, we basically, and I showed this to you a couple videos ago, we have the whole associativity of multiplication, commutativity of multiplication, that we can reorder stuff and be fine. So when we see 3a squared b squared times, 4a squared b squared times 3ab to the fifth, we can think of this as 4 times 3, that's 12. A to the second times a to the, there's a 1 there. A to the first. If I see multiplication, exponents are one level below. I should be adding. That's a to the third. And then we think of it as b squared times b to the fifth. Well, let's see. I see multiplication, so with my exponents, I should be adding. That's b to the seventh. B squared times b to the fifth, okay. B to the seventh. Done. There's nothing more we can do. This is multiplication of monomials. So we have two terms, we're just multiplying them. Two terms, just multiplying them. Well, now we have more than two terms. But that's still one term. So can we multiply a monomial times a polynomial? Now what's weird is that you've been doing this for a really long time. It's called distribution. That is literally what distribution of monomials is. That's what multiplication of a monomial onto a polynomial is. That's what distribution is across addition subtraction. We basically just say, well, we're going to take that monomial and multiply every single term, no matter how many they are, by that number. That's exactly the connotation of distribution of monomials. That's what's going on here. And we're fairly used to it. We know that we take this number up front, we multiply, so 2 times 6y, we know that's 12y. But then we also know that distribution is like playing cards. It's like if you're at the table and everyone's put their ante or whatever, you're playing poker, and you just deal out cards to everybody. That's what distribution does. It deals out whatever the monomial is, that single term, times every single term inside. It's dealing out cards through multiplication. That's all that's going on. So 2 times 6y, 12y. No big deal. We know how to do that. 2 times negative 3, well, I know that's negative 6, so if I think negative, I'm going to write minus. Now, I'm going to ask kind of a silly question, but can you go any further? Now, the answer is no. But why? Why can't you go any further here? Why can't you combine those? And the thing that should be popping in your head is, well, they're not like terms. You just taught us that in the last couple videos. Exactly. So don't forget what you've learned already. And what I mean by that is, as we're going through, we deal with lots of different rules. It's really easy to get them confused. It's not hard to do, but it's easy to get them confused. And that's two different things. While the operations aren't hard, it's easy to make mistakes. What I mean is that when you're doing these multiplications and then you switch to combining like terms, which is addition subtraction, we tend to get our exponent rules confused. So be very careful. Don't just go super slow on this, but slow down a little bit until you're really getting the hang of it, because I'd hate for you to start combining terms that are not like terms, doing silly things with exponents that we shouldn't. That's the idea. So this is kind of a recap of where we are right now. We know how to multiply. We know that terms, individual single terms times individual single terms, we take numbers times numbers, no problem. And what we do with the exponents is one operational level below what we see. So we also know how to distribute monomials. Let's put these two ideas together. And that's what the rest of these 5 problems are all about. If we look at something like this, yeah, it looks a little different, but that's still a monomial. That's still a polynomial with 2 terms. We can still distribute. We can still multiply a monomial times a polynomial. And we can still distribute those playing cards, if you will, through multiplication. We still go, hey, you get a card, and you get a card, and multiply that monomial times every single term inside. That's what distribution does. That's all it does. And that's multiplication of monomials. So let's give it a try. Now, I'm going to encourage you to do something. You see, when we're multiplying, we're going really fast, we have a tendency to overlook exponent rules. So what are we really doing? Like when you distribute, what operation are you seeing? This is big time. Don't miss this. What operation are you seeing when you multiply? Well, when you distribute. I just said it. You're seeing multiplication. So that begs the question, what do you do with the exponents when you're distributing? Well, distribution is multiplication. So I'm going to multiply terms like normal, like numbers times numbers, no problem. But what I'm seeing is multiplication. What I should be doing with exponents is addition. Well, what that means is that if you don't have an exponent up there, give it 1. Like literally, just give it 1. So when I'm looking at this, I'm not necessarily just looking at y, I'm looking at y to the first. I'm looking at 2y to the first. I don't need it on the 4, that's fine. That's just, don't worry about your coefficients or your constants. It's just the exponents that we're worried about. So just a short little recap. What am I doing? I'm distributing. Yes. What's that really mean? That means that I'm seeing the level of operations of multiplication. What I do with the numbers doesn't change. You're going to multiply. But what I do with the exponents is always 1 level below what I'm seeing. If I'm seeing distribution, multiplication, I should be adding the exponents. So we don't have to write any other work if you don't want to. That's fine. I just want you to put these 2 ideas together. When you multiply, you add exponents. Distribution is going to every term. Now, we're distributing, multiplying every term, and since we're multiplying, we should be adding the exponents. So I'm going to say it in my head. I always say this stuff in my head to make sure I don't make a mistake on it. Negative y to the first times negative 2y to the first. Negative times a negative is a positive. So I know I'm going to get positive 2. Numbers times numbers. Negative 1 times negative 2 is positive 2. Now our exponents. I had y to the first and y to the first. I'm multiplying. So let's see, I'm seeing multiplication. What I do with exponents is add. I'm going to get y to the second. Negative y to the first times negative 2y to the first is positive 2y squared. Done. That's awesome. Next, I know I need to multiply negative y to the first times 4. Well, that coefficient's negative 1, so really what we're doing is multiplying numbers times numbers. There's no variables to add exponents to. We don't worry about it. So negative y to the first times 4 is negative 4y to the first. I use this 1 so that I can see on adding exponents what to do. But when I get down to my final problem, this polynomial, I don't write it anymore. Now, one last question. Can we combine those? Can we keep going? And this is the part where students tend to confuse some ideas. They go, well, wait a minute. I mean, those you did something with, they're different powers, yet you were still able to get 7. Why can't I freaking get a y to the third? Because you have a different operation. When you're multiplying, we get to add exponents. Always one level below. When you're adding or subtracting, what do you do with the exponents? Well, whatever's below addition subtraction. Nothing. There's nothing down there, which means you can't combine them. There's no level below addition subtraction, so you can't add terms together if they have different powers. Because in order to do so, you'd have to change the exponents. Now, there's nothing to change them to under addition subtraction. So what you do is one level below what you see. If you're at addition subtraction, your exponents would have to be exactly the same so as not to change them when you add or subtract. So we're done. Those are not like terms, we can't combine them. Some other weird stuff, this looks a little funky, you just need to know about it, is that no matter where your monomial is, it's still distribution. So whether it's out front and we have a multiplication, or whether it's at the back and you have multiplication, it doesn't really matter. You're still able to distribute that. So when we do, we have this a to the fourth times 3a, and I'm going to do this, I'm going to have 3a to the first. So we're seeing distribution. Distribution is multiplication. I write my little power 1. So I'm multiplying a to the fourth times 3a to the first. That's going to be 3a to the, let's see, multiplication. I should be adding the exponents 3a to the fifth. Done with that term. Move on to the next one. You can see that this is going to go pretty quick when you get the hang of it. A to the fourth times negative 7, well, there's no exponents to even deal with there. That's negative 7a to the fourth, so I'm going to write minus 7a to the fourth. Now I check, can I combine like terms? They're not like terms. So those exponents aren't identical. Like terms are defined as having the same exact variable part. If they're not the same, then I can't combine them. Why? What you do with the exponents is one level below what you see. If you see subtraction, there's nothing below that. You can't, but you'd have to change those to combine them. But yet subtraction says, what do you do with those exponents? Nothing. You don't do anything with them. I mean, you subtract them and you wouldn't change them. They'd have to be exactly the same to not change them. They'd have to be like this. They go, oh, okay, that would allow me to combine those and still have the 5 and not have to change that. Last one, I want to encourage you to kind of pause here and just see if you can try it. It didn't matter if you get the wrong answer or not, but we've combined a couple ideas. We know about multiplication of monomials. We've done that already. We know about distribution in its basic form when you have a coefficient, or a single term that's a constant, like 2. We know how to distribute. We've just put those ideas together, and the idea of distribution is take your monomial, multiply every single term inside your parentheses times that monomial. See if you can try that here. If you're brave enough, try all of them. We're going to start with this one and do the same thing basically. We have a monomial 3x squared. We get this polynomial with 1, 2, 3 terms. What multiplication means is that what distribution means is that you are multiplying here. You're multiplying one term times all these 3 terms in here. We're just going to do it slowly. We're going to understand that what we're seeing is distribution. That means multiplication. What I'm doing with exponents is one level below. I'm adding the exponents. So let your numbers multiply times your numbers. No problem. You get 6. X to the... Here's the big mistake that people make. They get so used to multiplying, they go 6x to the 6th because they're going too fast for their own good. And it's really easy to make that mistake because I know you're multiplying 3 times 2. Why? Those aren't exponents. 3 and 2 are not exponents. Exponent rules can't apply to them. So you're not going to get 5. They're not exponents. Exponent rules only apply to exponents. So when we're multiplying, sure, we're going to multiply our numbers and get 6. Your exponents, what you do with your exponents is one level below what you see, so we should get 6x to the 5th. That's the idea here. Maybe give this a little power 1 so you don't forget that it's there. 3x squared times negative 5x. Let your numbers multiply times your numbers. Negative 15, right, minus. x to the second times x to the first. I'm always thinking multiplication, so if I think multiplication, I'm going to be adding exponents. That's x to the third. And lastly, 3x to the second times 6. Just 18x squared. Can you add any of those together? Of course not. Because they're different exponents, you can't combine any of those things. I'll make you a promise. If you can't combine your first polynomial and you only distribute one term, you'll never be able to combine this either. So that you'd be changing all the powers with the same exact addition. So if these aren't the same powers and you add to them the same number, those aren't going to be the same powers either. Those aren't like terms, you can't combine them. Hopefully you've given those two a try. I'm going to run through them pretty quickly. It's really just this combination of two ideas. This multiplication, so we're adding exponents, and the idea that distribution still works. What I would encourage you to do is give every variable you're multiplying, every variable up there, at least a power 1, because I don't want to forget that it actually makes a difference. Now, when we distribute, we've got one term, we've got two terms. If we distribute 2x to the first, y to the first, times 7x squared, y to the third, this is exactly like what we did right here. Exactly the same thing. You're just doing it twice. You're taking that monomial times your polynomial and hitting every term with it. You're basically doing this and this and this over and over again. So first time we have, well, 2 times 7, that's 14, no problem. X to the first times x to the second, let's see, I'm seeing multiplication, I should be adding, that's x to the third. Likewise, we get y to the fourth. 1 times y to the first times y to the third is y to the fourth. We have to add the exponents. Keep on going, 2y to the first, 2x to the first, y to the first times negative 3y to the first. Well, numbers times numbers. 2 times negative 3 is negative 6, right? Minus 6. Now with our variables, I don't have any other x's to multiply, so I can't change that x to the first, but I do have a y times a y. Y to the first times y to the first. I'm seeing multiplication, I should be adding. Y to the second. Let's double check. 2 times 7 is 14, that's good. X to the third, y to the fourth, cool. Negative 6, got it. No other x's got that one, and then y to the second. It's really hard to go back and check your work at this point. So in order to check our work, it's not like plugging in a solution like before. It's pretty easy. You find a point of intersection, you plug it in, and it works. Here, it's not like that. So you got to be really on your game in order to get these right. Okay, last one. The first thing I'm doing, I'm noticing the operation. I notice this is multiplication. I'm going to be distributing. I'm also looking at the number of terms. I have one term here. I have 3 terms inside that polynomial. I'm going to give every single variable numbers. I don't care about the numbers having exponents. I really don't. Variables, yes. So I have those variables up there having exponents. I'm going to use my exponent rules as I distribute. So I'm going to let my numbers be multiplied, like my coefficients be multiplied, but my exponent rules are going to take over for exponents. So negative 1 times positive 3. Negative 3. Notice how we can do basically all the operations separate. Multiply your numbers. Multiply each individual variable. No problem. That's okay to do for those monomials. I mean, shoot, we did it here, we did it there. Same thing, you're just doing it 1, 2, 3 times now. So negative 1 times 3, negative 3. X squared, there's no other x's. X squared. Y to the first times y to the first. Same multiplication, I should add y to the second. Done, that's your first term. Now we keep on going. Negative 1 times negative 1. I'm always multiplying my coefficients first. So negative 1 times negative 1 is positive 1. I'm just going to write plus. Because I know that whatever I write next, if I don't write a number, it has a coefficient of 1. That's that positive 1. If you really want to write the 1 and erase it later, that's fine too. X to the second times x to the first. I'm seeing multiplication. Distribution is multiplication. I should be adding. That's x to the third. Y to the first times y to the first, just like the last one, gives us y to the second. I'm going to take a moment, erase that 1. I don't need it any longer. Last one. Negative 1 times negative 2. Negative 1 times negative 2. Multiply my coefficients. That's positive 2. I'll write plus 2. Lastly, I have x to the second times x to the first. Okay, I'm seeing multiplication. I'll add x to the third. Y to the first time, there's no other y's. I can't change those exponents if I have nothing to add to it. Y to the first. So let's double check. Negative 3, cool. X squared, y to the second. Got that one. Negative times negative positive. X to the third, cool. Y to the second. I'm adding exponents here. Negative times a negative is a positive 2. X to the third, y to the first. I'm done. Now I could look to see if I could combine like terms, but since those are not like terms, whatever I get when I multiply a monomial to them are also not going to be like terms. My variables are not identical. That means same variables to the same power. If they're not identical, we have no chance of adding them. One last thing we're going to use in the next little video that we do. However many terms you have here times however many terms you have here. Wait a minute, aren't I going to have one term? Not necessarily. That's going to give you how many terms you have here. So 1 times 2 is 2. 2 times 1 is 2. 1 times 3 is 3. 1 times 2 is 2. 1 times 3 is 3. That happens every single time. And then we would check for combining like terms. That's the idea of how to distribute monomials in general. The idea is fairly straightforward. We've already multiplied monomials many times. We know we multiply numbers times numbers. Coefficients, no problem. That's a multiplication concept. What we do with the exponents is one level below what we see. So when we see distribution, which is a multiplication concept, we are multiplying the coefficients, no problem, but we are adding the exponents. That is about it. Make sure you hit every term inside that polynomial and you're good to go. I'll see you for the next video.